All right, guys, I'm looking at number 6 now. So it says, from the following noble gas notation, give 1, the name of the element, 2, its number of valence electrons, and 3, the ground state energy sublevels in which the element's valence electrons reside. Okay, so this is a good one for example 5-2, which is on page 110. But I'm going to go through, let's see, we'll do the second one for you, okay? The second one is looking at that. I'll just draw this out here. You've got okay. So it is saying, first part, name this element, right? Well, I know that I'm in noble gas notation because this right here is a noble gas. Remember, all of the ones in that column 18, those are noble gases. And so I'm going to look and see what my atomic number is for argon, right? So I'm going to look at my periodic table of elements, and argon, like right here, sorry, can you see? Has 18 protons, and that means it's got 18 electrons, right? So 18 electrons, and then, so I know that argon has 18 electrons, and then I'm just gonna add in these electrons. I've got 18, 19, 20, 30, 33, right? So since I have 30, this element is gonna have 33 electrons, which tells me that it has 33 protons, and that is the atomic number. So I'm gonna go back and look at my periodic table of elements and see which one is atomic number 33. Right, so looking here, I've got atomic number 33, I've got arsenic, okay? So this one, so the answer to the first part is arsenic. Okay. And then the second question says its number of valence electrons. So again, on page 110, if you read valence electrons, they're the electrons that are in they have the highest principal quantum number. They're the electrons that are in the outermost shell, basically. So these are going to be really important for whenever we're looking at bonding in future chapters. They really determine the properties of a lot of these elements, okay? But what you need to know right now is that valence electrons are the electrons that have the highest principal quantum number, which is basically the ones that are in the highest energy level, okay? So if I look at this right here, right? I know that arsenic, everything is going to be, for arsenic, is going to be in energy level 3, I think. Let me look here. Because arsenic is in the 3rd energy level, right? So looking here then, I'm in the 4s, right? I'm in the 4s here. So my answer is I've got 2 electrons in 4s and 3 electrons in 4p. These right here, they're still in the 3rd energy level. So and remember, by definition, valence electrons are the electrons that have the highest principal quantum number, right? So this 4 is higher than 3, right? So this is the highest principal quantum number right now is 4. So I have 5 valence electrons, 2 plus 3, okay? And so then my third question for that, I think we already answered, but it says, give the ground state energy sublevels in which the element's valence electrons reside, right? So 4s has 2, right? 4s has 2 valence electrons, and 4p has 3. All right, so that is number 6. Guys, now that I did 5 and 6 for you, you know, like a really good bit of information on those, I think that, so number 7 is exactly the same. It's just written a little bit different. So instead of writing it as noble gas notation like this, it's written in the orbital notation, right? It's written this way, except for they put the noble gas with the noble gases, right? So does that make sense? So let me see here. So basically, right? So if I'm looking at, let me take those away real quick. So if I'm looking at argon, right? What we just did, or I'm sorry, arsenic. This right here is argon. What they did was they wrote it as 4S and then 3D. And remember, D has 5 subshells, right? And it says we have 10 electrons in those, so we have all of them filled. Sorry, don't mind my arrows. I learned to write half arrows in college, so you can write half or full arrows. And then for P, remember P has 3. 1, 2, 3 subshells. There's only 3 electrons in that one. 1, 2, 3. Hund's rule, we're going to put 1 in each before we fill up. Okay, so basically, instead of writing it like this for number 7, they just wrote it like this, okay? So then all the other questions are pretty much the same for 7. And number 8, let's see number 8. So yeah, after you've gone through all of these, you could probably look then and see number 8, you know, kind of what's wrong. It's really just analyzing what they have there. And if you understand what we've gone through with numbers 5, 6, and 7, number 8, you should be able to decipher what is incorrect about how they wrote those notations, right? About magnesium. So anyways, go ahead and give the rest of those a try. Bring them to class on Wednesday. Really give them a good shot. Again, go back and look at those examples because they really walk you through how to do each one of these problems. Thanks, guys.